Thank you. Your time is precious, and I appreciate it. I appreciate you stuck with it for the day. Also, thank you to someone who isn't in the room but has been here all day. Amanda, thank you very, very much for the live captioning that you've been doing. Thank you to Mozilla and Whitecoat Captioning for doing that. Really appreciate it. Oh, a bit of housekeeping. I'm contractually obligated by the Public Speakers Guild as the last speaker of the day to say that I am the only thing standing between you and going for a beer. So with that out of the way, I feel like in this situation now, because it's been 2 days of like intense talks, I just want to point out that you are the only thing standing between me and going for a beer. So I would like to talk to you, which is kind of weird when you think about it. I mean, on two levels. One, that I'm here to talk to you, like some clerical error on the part of Mozilla that's ended up with me here. But I'm going to talk to you. Like, I'm literally going to stand here on the stage, waggle my jawbone up and down, move a fleshy piece of meat and muscle around inside my mouth, and pass air through my throat for like half an hour or so, right? And you're just going to sit there and take it. It's kind of a weird activity, what we're doing here, me talking. But of course, the reason why it works is because I will be using language as I do it. And hopefully we've all got the same code base in this particular language, English in this case. Language is amazing. I mean, language is one of the things that kind of makes us human. It was certainly one of the great leap forwards in human civilization. Maybe 50,000 years ago, the dates are fuzzy. I mean, through language, just through moving my jaw and waggling this piece of fleshy meat and passing air through my vocal cords, I can tell you something that happened, and then you are able to revisit the past. Or I can imagine something in the future and relay that to you, and you are able to travel to the future through language. So language is a kind of time travel. On a more basic level, it's a form of communication, which is also amazing. In other words, I can have an idea inside my brain, and then I move my jaw up and down, flap the piece of fleshy meat, pass air over my vocal cords, vibrate the air between us, and transfer that idea from my brain into your brain. So then language is like a virus, right? It's almost involuntary. I can say, don't think of an elephant. You thought of an elephant, right? That's kind of the auditory equivalent of the chicken game. You've played the chicken game and lost. That phrase, don't think of an elephant, that's from a book by George Lakoff. He's written a number of books on language, and one of them, he wrote Women, Fire, and Dangerous Things, and he wrote this one back in 1980, Metaphors We Live By, because he's particularly interested in how we use metaphor in language. And this conceptual metaphor, which is the kind of metaphor we're always used to, where you talk about one thing in terms of another thing. And it's really useful when you're talking about something intangible. So time is a classic example. We can talk about time like it's a physical object. We talk about time moving through space. Time flies, time drags. Or we can talk about time as though it's a resource, saving time and wasting time. You can't do any of these things with time. Time doesn't do that. Time is intangible. But talking about time with a metaphor like that helps us conceptualize it. But what George Lakoff was interested in is cognitive metaphors. Political language in particular is something that's kind of fascinating. It's the idea that the framing we use in language could maybe affect the way we approach thinking about things. Not in a Sapir-Whorf way, but just a simple example is, he says, if you're going to have a debate about tax relief, well, before the debate has even begun, you framed taxation as something you need relief from. Right? So that's framing our thinking. I think we are guilty of this too on the web, you know. I'll give you an example. We talk all the time about what you can do now in the browser. The browser. Singular, not browsers. Maybe this frames our thinking. So I'm fascinated with the language and the metaphor we use to talk about the web as a medium, and also to talk about ourselves. The language and the metaphors we borrow to talk about ourselves. So the web's a relatively new medium, and what happens with new mediums is you tend to borrow from the medium that came before. This isn't new. This is something that Scott McCloud talked about in his book, Understanding Comics. This book I have actually read, because it's a comic book. And he's talking about how every medium borrows from the one before, right? He points out that, you know, many early movies were like filmed stage plays. And then a lot of television was just like taking radio and just adding pictures to it. And it takes time for the new medium to evolve its own vocabulary, its own metaphors, its own tropes. Now, this resonated with me because it reminded me of something I had seen written somewhere else, and that was in an article called A Tao of Web Design, written by John Alsop and published in a list apart in the year 2000. Who has read, by show of hands, who has read A Tao of Web Design? Good, that's what I like to see. John makes the exact same point in this article. He says, every medium borrows from the medium before, and it takes time. Terrific article, by the way. I highly recommend you go and read it if you haven't. Even though it's 19 years old, it's more relevant now than when it was written, which is kind of amazing. And John says this. He says, when a new medium borrows from an existing one, some of what it borrows makes sense, but much of the borrowing is thoughtless ritual and often constrains the new medium. And over time, the new medium develops its own conventions, throwing off the existing conventions that don't make sense. So on the web, in the early days of the web, the medium that come before, if you were a designer, was print. And there's a lot to be learned from print, but it's not the web. And designers kind of wanted to recapture that control that they were used to in print on the web. And that's where we got stuff like this, Creating Killer Websites by David Siegel. This was 1996. Does anybody remember this? My fellow gray-haired friends. This was the guy who came up with tables for layout and spacer GIFs, all the stuff that Tejas was talking about earlier, so that you could get that control. And this is kind of what John Alsop was pushing back on in A Tao of Web Design, that maybe, control shouldn't be what we're after on the web. Here's what John said. The web is a new medium, although it has emerged from the medium of printing, whose skills, design, language, and conventions strongly influence it. Yet it is too often shaped by that from which it sprang. Killer websites are usually those which tame the wildness of the web, constraining pages as if they were made of paper. Desktop publishing for the web. But he does acknowledge that, yes, we have a lot to learn from this history of not just print, but pre-print, right? Layout, illuminated manuscripts. You can see things like drop caps and layout and all this stuff evolving over time, reaching its zenith with the Swiss School of Design in the 20th century. This is the next leap forward after language, is writing. Now we can communicate ideas, and you don't even need to be in the same physical space. We don't have to vibrate the air between us anymore. I can just make marks on wood, and I can put an idea into your head. Kind of amazing. So with this kind of debate, I guess, between, John also was talking about the Tao and the flow and the flexibility of the web, the wildness on one hand, and then you've got David Siegel talking about constraining things into, control on the other. They seem to be, two very opposing viewpoints, right? And they are. But they also have an agreement. Because what they're agreeing on is the language they're using as they talk about the web. Because both of them are talking about making websites. Web sites. Right? That in itself is a metaphor. Oh, I know it's very unfashionable these days to talk about websites. None of us make websites anymore, right? We're all making web app experiences. Websites? How very dare you? But no, let's face it, we're making websites. And that itself, that idea of a site, is something you go to, a building site, a construction site. I mean, that was literally how we thought of it in the early days, right? That our pages were under construction. I'll give you the full nostalgic effect. We used to actively say, oh, this is under construction. Let's face it, it's always under construction. We just stopped putting these animated GIFs on our websites. The web is constantly under construction. So I'm interested in these metaphors, how we talk about ourselves on the web, how we talk about our work. Now here's one that I hear a lot. We're talking about what we do and how we borrow from another medium. We talk about our work as though we are architects, right? Everyone wants to be an architect, which is funny because you actually talk to architects about the industry, like it's terrible. It's a dumpster fire. Like it's all about competitions and prizes and unbelievable spec work. Like, no, but still, everyone wants to be like an architect. I blame Hollywood for this. It's kind of become shorthand in screenplays that, you want likable person, oh, they're an architect. Right? The villain is never an architect in the movie. And there is a lot we can learn from architecture, just as we can learn a lot from print. I know many UX designers who consider this book to be the best book they've ever read on UX design. It's not about UX design. It's 101 Things I Learned in Architecture School by Matthew Frederick. It is about architecture, but a lot of the ideas and the messages are absolutely transferable to other mediums. There's another book in architecture that's definitely had an influence, not just on the web, but before the web, on software in general. That's A Pattern Language by Christopher Alexander. This is a classic book. By classic book, I mean a book everyone's heard of and nobody's read. It's 1977, and it influenced people. Ward Cunningham, who invented the wiki, he was influenced by pattern language. The Gang of Four, right? Their design patterns, elements of reusable object-oriented software, directly influenced by Christopher Alexander, because he's talking about breaking things down into modular, reusable components. I mean, come on, that's like design systems, right? So hot right now. This absolutely resonates. What's funny, actually, is there was a book by Molly Wright Steenson, Architectural Intelligence, where she specifically looks at the influence of product design, designers, architects on the digital world. And she points out that, yeah, Christopher Alexander has had huge influence in the digital world and almost no influence in architecture. Like, architects don't like him. They think he's kind of preachy. But on the web, do we ever like it? I ran an event all about components and patterns and design systems. I did it for a couple of years at Patterns Day in Brighton. And it was great, right? We got Gina Ann and Alec Holmatova and all these fantastic speakers. By the end of the day, I was saying, we really should have had a drinking game during the day, which was if someone mentioned A Pattern Language by Christopher Alexander, you'd take a drink, because it was that prevalent. In fact, here's the full drinking game I came up with was, anytime someone says Christopher Alexander, take a drink. Anytime someone says Lego, take a drink. Anytime someone points out that naming things is hard, take a drink. Anytime someone says atomic or atomic design, take a drink. And anytime someone says bootstrap, you puke it all back up. Now, there's another book in the world of architecture that's kind of had a roundabout influence, certainly on me. How Buildings Learn by Stuart Brand. Again, classic book. 1994. There was a TV series that went with it as well. And in this book, Stuart Brand looks at the work of a British architect named Frank Duffy. And Frank Duffy had this idea about buildings being not so much structures in space, but layers of structure in time. He talked about something called shearing layers. The way he said was, a building, properly conceived, is several layers of longevity. So he mapped out these layers, these shearing layers, right? So you think about the site that a building sits on, you're talking about geological time scale. And then the structure itself, you hope will last for centuries. And then, the walls, the plumbing, the time scales get shorter until you're talking about furniture inside a room that you can change on a daily basis, right? So all these layers moving at different speeds. This is shearing layers. So he was interested in the time scales here, but I spotted something else about shearing layers, which is that each layer depends on the layer before. You can't have the structure until you have a site to build on. You can't move stuff around in a room until you've made the walls and the doors, right? So this idea of each layer in the shearing layers, depending on the layer before, it reminded me of something I'd come across in the work of Stephen Johnson, who's written a number of books about where good ideas come from. And he's keeps going back to this idea of the adjacent possible, that certain things need to exist before you can create something, right? The adjacent possible, he says, is why you don't get the microwave oven invented in, medieval Europe. There's too many other steps need to happen. The World Wide Web itself, there's so many steps to that. First, you have to have industrialization, so we get to have electricity, which leads to circuitry, which leads to computers, the internet, the World Wide Web. And you can keep going further, right? On top of this, you build services like Facebook, Google. They depend on the web, which depends on the internet, which depends on computers. So these layers of stuff that's built up, and again, probably with the timescales too, and they depend on the layers below, the adjacent possible and shearing layers. Now, Stuart Brand revisits this idea of shearing layers in a later book, The Clock of the Long Now. So Stuart Brand's one of the co-founders of the Long Now Foundation. Anybody heard of the Long Now Foundation? Raise your hand. Any members of the Long Now Foundation? All right, for once there's a member, great. Yeah, dedicated to long-term thinking, the Long Now Foundation. Longnow.org is the website. If you go to the website, you'll notice that all their years use 5 digits. They begin with a leading 0. Got to avoid the Y10K problem. And they're building a clock that will tell time for 10,000 years, which is really fascinating. I highly recommend looking at design principles for something that's supposed to last for 10,000 years. So in this book, Clock of the Long Now, Time and Responsibility, the ideas behind the world's slowest computer, Stuart Brand kind of abstracts shearing layers from architecture and applies it to everything. That shearing layers are just everywhere. And he calls this pace layers, this idea of just different layers of time scales. And he gives an example by taking us, the human race, and looking at the pace layers of the human race. That the sort of slow bottom end, you've got our physiological nature, our DNA. That doesn't change for tens of thousands of years. Physiologically, there's no difference between a caveman and an astronaut. Culture builds up over centuries, right? How we identify as tribes with language, with countries, all this kind of stuff. Governance, not governments, governance, systems of governance, they tend to stick around for quite a while, but they can change, maybe sometimes through revolution. Infrastructure needs to move faster than that, but not too fast. Commerce, very fast moving. Right? And then fashion moves really quickly. So he maps these pace layers onto this diagram, right? Where you got the really fast moving stuff up the top and the slow moving stuff down the bottom. Now when he talks about fashion, he's talking about stuff like pop music, where everything's supposed to change really quickly. Try this, no, try that, what about this? And it's good that it moves fast, right? It would be really dull if fashion moved slowly. Right, you want it to. And interestingly, some stuff, the good stuff from the fast layers, will make its way down into the lower layers. Like a really good pop song may become part of culture. So the way that Stuart Brand talks about the interactions between these fast layers and slow layers is he says, fast learns and slow remembers. Fast proposes and slow disposes. Fast is discontinuous. Slow is continuous. And fast and small instructs slow and big by a crude innovation and by occasional revolution, but slow and big controls small and fast by constraint and constancy. And he says, fast gets all our attention, but slow has all the power. Now this idea of pace layers, I'm hopefully going to be transferring from my brain into yours. I kind of feel bad. It's because the problem is I see pace layers everywhere now. Like when a typographer points out bad kerning to you, it's like, thanks, you've ruined my life now. I can't unsee that. That's what it's like with pace layers for me. It's a joke at work at Clear Left. We'll say, time to pace layers. How long before somebody points out that this is like pace layers? It's like, you remember the first time someone points out the arrow in the FedEx logo? Right? And then that's all you see now. FedEx truck goes by, all you see is the arrow. You've seen the arrow, right? Yeah, right? Yeah, okay, good. Oh, okay, what about this one? What about the Toblerone logo? Who sees the bear? Wait. You see the bear? Okay, you won't be able to unsee that, right? That's the virus I put in your head. Or, consider the duck. A perfectly normal duck. Until you're on the internet and someone points out that all ducks are actually wearing dog masks. All ducks are actually wearing dog masks. And now, when I show you the same picture of the same duck, you cannot unsee that. And that's what it's like with pace layers for me. It's like, I see them everywhere. So I thought, can I apply pace layers to the web, to where we work? And I've given it a stab, and I think it kind of works. So at the sort of bottom layer, the slow-moving layer, you've got the internet itself. TCP/IP hasn't changed since Bob Cannon, Vint Cerf basically wrote the protocols in 1974. And that feels right. We'd have to rip everything out and start from scratch. HTTP, all these other protocols sit on top of TCP/IP, right? We've got protocols for email, protocols for file transfer, and protocols for hypertext. Now, HTTP has changed. We've got HTTP2 now, but the pace of change tends to be pretty gradual. It takes time. And again, that feels right. It feels like it shouldn't move too quickly. Then we put URLs on the web. Now, I would love it if URLs were down here at the bottom layer. URLs never change. I wish that were the case. We must acknowledge that URLs absolutely change, disappear, they rot, but we can fight against the rot, and I think we should. And what do you put at that URL? The obvious answer is you put some hypertext with HTML, right? You got structure. Now, HTML has changed. I mean, when HTML was first created by Tim Berners-Lee, borrowed all these tags from SGML, and it was about 25, 26 tags, or elements, as we would say today. And now there's well over 100. But you know, spread over the lifetime of HTML, the pace hasn't been too quick. Like, I feel like I've been able to keep up with the pace of change with HTML. And CSS, I feel like it moves faster. Certainly these days, there's more and more newer stuff coming in CSS, which is great. I mean, now that we've got Grid and Flexbox and all this other stuff. But again, I feel like, this is good. I can keep on top of this. You know, I follow the right blogs, I keep track of the right people. And then there's the JavaScript ecosystem. Not JavaScript the language, I'm talking about JavaScript and friends, right? Like the libraries, the tools we use for JavaScript. And this is like, I give up. It's too fast. So, well, you're still using that, right? That's so last week we've switched over to this. Oh, I can't believe you're still using that tool. So, show of hands if anyone else feels like this when it comes to the pace of change with JavaScript. Now keep your hands up, and just take a look around. Okay? You're not alone. This apparently is the new normal. What's interesting is, though, remember, fast learns, slow remembers. So it's kind of the point of JavaScript to go, what about this? What about that? Try this. No, try that. And over time, the good stuff makes its way down. Consider, you know, when I was first making things with JavaScript, showing my age now, but the common uses were things like image rollovers, right? You mouse over something, the image changes. Or form validation. Somebody's typing something into a form field. Is that actually an email address? Was that required field filled in? I use JavaScript to do that. Now today, I would not use JavaScript to do that. I would use CSS to do a rollover, hover. I would use HTML, input type equals email, required, to do form validation, right? Fast learns, slow remembers. Those things filtered down. You know, we needed a solution for responsive images. We figured it out in JavaScript, and then it moves down into HTML. So mapping these things out helped me with feeling overwhelmed by the pace of change in JavaScript, because I realized it's kind of supposed to be that way. It's the tippity top of the layers, and it's meant to be trying lots of new stuff and changing things quickly. You know, if I want to go somewhere that's a bit, slower moving, I can spend my time in one of those other layers. So something else I noticed when I mapped this out like this, it's like, this order of things, this layered structure, that's kind of how I build websites too. Right? I mean, I assume the presence of the internet, although now with service workers, you can even get around that. But, it's like, okay, URL design is a place to start. I think that's a great place to start designing something. And then thinking about the structure of your content with HTML before thinking about the presentation. And then adding JavaScript on top of that for the behavior and the really powerful stuff, right? This really maps to how I like to build, in layers. However, it is a testament to the flexibility of the web that you don't have to build this way. If you want to, you don't have to use all the layers. You can, if you wish, build like this. You can assume the presence of the internet, and then everything on top of that, do it all in JavaScript. URLs, routing, let's do it in JavaScript, in the client. HTML, we're going to put some text on a screen. Yeah, let's use JavaScript for that. CSS, in JS, please. And of course, everything on top of that. Now, this is literally the architecture of single-page apps, right? So you can use this architecture rather than using the layered architecture. Now, personally, I don't like this architecture. It doesn't sit right with me. I'll tell you why. Because you've kind of turned it into this single point of failure rather than, gradients of failure, where if you've got JavaScript, everything is great. If you don't have JavaScript, you get absolutely nothing. So it turns it into a binary situation. It either works great or it doesn't work. I'm not talking about people switching off JavaScript. I'm talking about something happens on the network, something happens in between, and you get absolutely nothing. Now, this way of thinking, this binary way of thinking between something either doesn't work at all or works great, makes total sense in other mediums. If, for example, you're building a native app for a phone, you're building an iOS app, and I have an iOS device. Great. I get 100% of what you've designed and built. It works great. If you're building an iOS app and I have an Android device, I get 0% of what you've designed and built. It just doesn't work at all. So that mindset makes total sense in a lot of software situations, but not on the web. On the web, it is possible for us to build like this, where we can build in layers so something goes from not working at all to just about working, to working better, to working really well, to working great. Now, you might design something and you're imagining it works 100%, and maybe because of the device I'm using or my browser or my network, I don't get 100% of what you've designed and built. But I probably won't get 0%. Maybe I get 80%, maybe I get 90%, depending on the situation and the circumstances. I feel like that's better than the binary situation. And what's really nice about this approach to building on the web is that it maps so well to the technologies we use for building on the web. A layered approach. Now, I'm not the only one who thinks this way. I'm going to quote from Ethan Marcotte. He says, "I like designing in layers. I love looking at the design of a page, a pattern, whatever, and thinking about how it'll change if, say, fonts aren't available, or JavaScript doesn't work, or if someone doesn't see the design as you or I might, and is having the page read aloud to them." It's just kind of anticipating the unexpected. Now, Ethan, of course, we all know from writing an article on a list apart. This time it was back in 2010. It was called Responsive Web Design. You might have heard of it, right? What's interesting, so same place where John Alsop published his article in 2000, and Ethan begins his article by quoting John Alsop's article, by building on top of it another layer, if you will. And this term that Ethan comes up with, responsive web design, it was borrowed directly from architecture. In architecture, there's a school of thought called responsive design, about buildings responding to the people within them. So, architecture, actually a pretty rich theme for metaphors and language to describe our work. There's another area of work that we've borrowed, we've taken from, so that'll do nicely very much. And that's when we describe ourselves as engineers, software engineers. Now, I will admit I have a soft spot for the term software engineering, not because of the words itself, the metaphor, but from where it comes from. Margaret Hamilton was, she coined this term, software engineering. Margaret Hamilton wrote the code for the Apollo command module, code that was then literally woven into the computers for the greatest endeavor that our species has ever been involved in. I think like the perfect mixture of software, hardware, and human beings working together to get human beings onto the moon. Absolutely amazing. By the way, I should point something out about this particular picture. You're familiar with the selfie, a kind of self-portrait photography popular with the youth. This is one of the few examples of an everyone elsey. It's Michael Collins, Buzz Aldrin, and every human being alive at the time. The only person not in the picture is, Buzz Aldrin and Neil Armstrong. Michael Collins taking the picture is the only person who is not in this picture. It is an everyone elsey. So engineering, software engineering. I feel like if you're sending people to the moon, yeah, that does feel like engineering. And there's all kinds of engineering. There's chemical engineering, mechanical engineering, industrial engineering. Let's try and see what unites these various disciplines that all fall under this engineering umbrella. I think it's the fact that you've got what you're working with is the materials that you're working with and the tools that you use to work with those materials. So let's see if that can apply to the web. Well, as we've seen, I think the materials of the web are HTML, CSS, and JavaScript, hopefully in that order. As in, that's what the end users are going to get. No matter what tools you use to build with, that's ultimately what the end users will get. Now, what tools do you use to design and build on the web? There's the obvious tools, like graphic design tools, the Photoshops and the Sketches. Yeah, goes out to graphic design tools. Though I sometimes feel like graphic design tools can influence our thinking in much the same way as political language can, right? Like you open up a Photoshop document, you want to make a new Photoshop document, the first thing you do is put in a width and a height. And straight away you're thinking back in that killer website constrained way. Anyway, these are obvious tools to build with. And there's the less obvious tools that we definitely use if we're working on a web project. You know, we have to communicate, whether it's email or Slack and calendars and meetings and all that stuff. These are productivity tools, though I know sometimes it feels like we are not being productive when we're using these tools. But when you think about it, it's kind of an oxymoron to say productivity tools, because that's literally what a tool is. All tools are productivity tools. That's what tools do. But I think we should acknowledge these are also tools that are necessary to build something. And then let's dive deep to specifically, what about when we're developing, right? We're designing, we're communicating, collaborating, and then we go to develop. There's a whole bunch of tools we can use. Version control and task runners, build tools, pipelines, pre-processors, post-processors, all these tools. Now, I've kind of lumped all of these together because what they share in common is that they sit on your computer, right? And they're productivity tools. They're there to help you work faster. The end user doesn't see any of that. Right? They don't directly touch the end user. You can say, oh yeah, but because we work faster, there's a benefit to the end user. Yeah, but not directly. So when it comes to these things, I feel like, well, because they sit on your computer, use whatever you want. Use whatever makes sense to you or your team. Like that should be the defining factor. I will admit, again, like with the JavaScript ecosystem, I'm a bit overwhelmed with the pace of change. Again, it's like, oh, you're still using that particular task runner? Whoa, we changed last week to this new one. It feels like maybe sometimes, I understand you're working at scale, you need these complicated tools, but does it always have to be that way? Does it always have to be so complicated? What it reminds me of is, do you remember that startup that was like before Bodega, the Silicon Valley poster child? Juicero? Right, it was like a really expensive machine, and it makes juice. And you buy the expensive machine, and you buy the expensive packets of juice, and you put the expensive packets of juice into the machine, and you got juice. So it did what it was supposed to do, it made juice. Well, somebody pointed out, you could just squeeze the packet by hand. I'm just saying, you can just squeeze the packet by hand. I'm being disingenuous. I know, like, if you're just making juice for a few people, you can squeeze it by hand. If you have to scale to giving juice to thousands or millions of people across the globe, then you need... so this is where metaphor breaks down, I think. So I'm going to leave that. But as well as the materials and the tools, and here's the thing, when you're choosing those kind of tools, right, your task runners, your minifiers, whatever, yeah, use whatever works for you, that's fine. There's a whole other class of tools where that's not true, and that's the tools that are actually written in the materials themselves. So if you're using a CSS framework to make your life better as a productivity tool, that's fine, but now you're making the user download the framework. So you're making the user download the framework so you, the developer, get the benefit. If you use a JavaScript framework on the client side, then you're making the user download the framework so you get the benefit. They're paying the tax. And if you use it on the server side, then it goes back to being one of those tools that's basically sitting on your computer, right? Just pointing that out. I think when it comes to the tools that are built in the materials, frameworks and libraries built in the languages that are, and those things are then delivered to the end user, you cannot just say, hey, use whatever works for you. Use whatever's best for you or your team. I think you must consider the needs of the users over the needs of the engineers. At the very least, there's a balance to be had there, and I would rather weight the balance in terms of users than engineers. Hey, I like developer experience as much as the next developer, but user needs, they've got to come first. Now, when you're choosing tools, there's a lot of questions you can ask about. Is this an appropriate tool? Is this going to help me? And one thing to ask is, well, how well does it work? That's the obvious question. Should I use this tool? How well does it work? But something to ask, especially if it's something that's going to be used to directly impact the end user, something the end user is going to have to download. And a really important question to ask is not how well does it work, but how well does it fail? What happens when things don't go perfectly? And now we're back to that situation of the single point of failure, right? Because if you're building that binary way where it's like the internet and JavaScript and nothing else, it fails really badly. It either works great or doesn't work at all. But this layered approach to building fails really well. Something does go wrong. You know, one of these whole layers, or within the layer itself, you use some CSS that isn't 100% supported in every browser. Oh, it's fine, right? Browsers will just ignore that bit and move on. Great error handling. Use some HTML that isn't 100% support it. That's absolutely fine. These technologies fail well. Which brings us to something interesting. So, JavaScript's the more powerful technology, but it doesn't fail as well as HTML and CSS. So you make one mistake in one line of JavaScript, everything after that won't get parsed, right? Well, this is kind of a good example of a principle, a law of nature, that was kind of underlying the creation of the web itself. The principle of least power, which states that you should choose the least powerful language suitable for a given purpose. That seems a bit weird on the surface. Why would I choose the least powerful language to do something? But when you think about it, the least powerful language is also going to be probably more ubiquitous, probably going to last longer, less prone to failure. Derek Featherstone puts it this way. In the web front-end stack, HTML, CSS, JavaScript, and ARIA, if you can solve a problem with a simpler solution lower in the stack, you should. It's less fragile, it's more foolproof, and just works. Right, so he's talking about the resiliency of it. Yes, you want to build a clickable button. You could do that with JavaScript and generate a div, and then you've got to add the event handlers and put the ARIA roles on it, or just use a button. Right? The lazy solution is the better one. That's a classic example of the principle of least power. I think this really matters on the web, particularly when it runs straight into another law of nature that definitely applies on the World Wide Web, and that is Murphy's Law. Anything that can possibly go wrong will go wrong. Edward Aloysius Murphy Jr., aerospace engineer, and because of this attitude, no one ever died on his watch, right? I think we're a bit quick to say, oh, everything will be fine, right? Edge cases. I mean, can you imagine if other industries did that? Car manufacturers, they strap crash test dummies into cars and smash them against walls at high speed. Admittedly, initially they didn't, and there had to be regulation to make them do it, but still, they're considering these situations, trying to make things safer, that they will fail well. Can you imagine if they went, hey, we've been looking at the data, and we're going to stop strapping crash test dummies into cars and smashing against walls at high speed. Turns out, most of these cars are being driven by humans, not crash test dummies, and most of them are being driven on roads and not being smashed into walls at high speed. It's like, yes, of course, that's the happy path. That's the situation we hope for. But you hope for the best and you prepare for the worst. And we are not preparing for the worst. Edge case. Here's what Trent Walton says. He says, like cars designed to perform in extreme heat or on icy roads, websites should be built to face the reality of the web's inherent variability. The reality of the web's inherent variability. This is exactly what John Alsop was talking about 19 years ago. And whenever there's discussion of engineering, something that always comes up is bridges. It's a metaphor, but I'm going to use it. I'm going to talk about a particular bridge. This is the Quebec Bridge. Cantilever Bridge. Construction started in 1904, after there was an architecture competition. Theodore Cooper was the engineer in charge of the firm that won that particular competition. And one of the first things he did was he lengthened the bridge from 490 meters to 550 meters. Mostly because he wanted it to be longer than the Firth Bridge, right? So it'd be like the longest bridge in the world. But he didn't recalculate the already high stresses being put on the steel. Also, Theodore Cooper wasn't based in Quebec. He was based in New York, and he refused to work on site. And when the idea was put forward that other people could double-check his numbers, he really didn't like that. There would be no code reviews on this project. So construction's happening, it's 1907, and on August 6th, a young engineer, Norman McClure, he noticed that there's bending is starting to happen. And he sees it again on the 27th of August, and it's gotten worse. So they're informing Cooper, who's down in New York, and Cooper does send a telegram back. He sends a telegram back that says, place no more load on Quebec Bridge until all facts considered. But he didn't explicitly say, stop working. So they didn't know how to interpret this telegram, and they kept on working. And it was a day or two later, and it was right before the end of work. Like the whistle was just about to blow when the bridge collapsed. And 75 of the 86 workers died. Something interesting started happening in Canada years later. It's 1925. And Canadian engineering schools started holding a new private ceremony. This is separate from your qualifications and getting your degree. This was the ritual of the calling of the engineer. You'd speak an obligation, and you'd be given an iron ring, a symbol, a metaphor of pride, yes, but also humility. You'd wear it on the little finger of your working hand so that it would, brush against the paper or the keyboard and be there as a constant reminder of responsibility. And that's why I take issue with us just deciding to call ourselves engineers. We haven't earned it. So what do? Why do we call ourselves architects, engineers? Developers, not bad. I think maybe we got it right back in the GeoCities days when we just talked about building things. Yeah, maybe we're builders. We're just like working bricklaying, collaborating together to make things. I mean, is that so bad? That we work together and we build. Maybe it's not engineering, maybe it's not architecture. But Christopher Alexander did say, and this influenced his thinking, he said, most of the wonderful places of the world were not made by architects, but by the people. Maybe I don't mind thinking of myself as a bricklayer. Not when we've got such amazing bricks to work with, right? Yes, it's a metaphor again, but think about the web, hypertext, the link. I mean, what an amazing brick the link is, right? I can make a page at a URL, and I can link to another URL, and some other URL over there. And that combination of links has never existed before in the history of the web. That's an amazing thing. It's kind of magical. I think we forget the magic. I honestly think it is the next step in our civilization, that we've gone from language and then writing and the printing press to the World Wide Web and hypertext. That it's the next layer on top of all those layers. And that we can choose to build amazing things. I'll finish with this apocryphal story about a traveler in the olden days. Comes across three workmen who are, putting stones one on top of the other, building something. He says to the first worker, what are you doing there? He says, I'm, putting stones, stacking stones. Okay. Bricks. He says to the second worker, what are you doing? He says, I'm making a wall. They're all doing the same thing, right? But they give different answers. I'm making a wall, stacking bricks. He says to the third builder, he says, what are you doing? He says, I'm making a cathedral. So maybe, it's less about how we describe ourselves, what language we use, and much more about what we build together. We are bricklayers. And over the last 2 days, you've heard from some really amazing bricklayers. Bricklayers, people who are building websites and web apps, building browsers, building businesses, building communities, building the web. And what an honor and a privilege to be involved in the construction of the web. But after 2 days of hearing from these bricklayers, my mind is full. And I feel like we need to stop now, so I'm going to stop moving my jaw up and down and flapping the fleshy piece of meat in my mouth and moving the air over my vocal cords and simply say, thank you.